Have you ever wondered how to compare two groups statistically? Or perhaps you're curious about how researchers determine if the difference between two sets of data is significant or merely due to chance. Today, we delve into the fascinating world of statistics and explore an essential tool used in this field, the T Test. The T Test, named after William Seeley Gossett's pen-name student, is a statistical hypothesis test that allows you to compare two samples to see if they come from the same population. To put it simply, it helps you determine if two groups differ significantly on some single categorical characteristic. So how does one go about conducting a t-test? The first step involves stating your null hypothesis and your alternative hypothesis. The null hypothesis usually suggests that there's no significant difference between the means of the two groups. On the other hand, the alternative hypothesis proposes that there is a significant difference. Next, you need to determine the level of significance, often denoted by alpha. This value, usually set at 5%, is the probability of rejecting the null hypothesis when it is true. It essentially represents the likelihood of a type 1 error, which occurs when we mistakenly reject a true null hypothesis. The third step requires you to calculate the t-statistic. This value is a ratio that looks at the difference between two groups' means and divides it by the variability in the two groups. A larger t-statistic indicates a larger difference between groups, while a smaller t-statistic suggests less difference. Then, you compare your t-statistic with the critical value from the t-distribution table. If your t-statistic is greater than the critical value, you reject the null hypothesis. Conversely, if it's smaller, you do not reject the null hypothesis. Finally, you interpret your findings. If you've rejected the null hypothesis, it means the difference you observed is statistically significant. If you haven't rejected the null hypothesis, the difference could be due to random chance. To illustrate, imagine a pharmaceutical company wants to test a new drug. The company might use a t-test to compare the recovery times of patients who took the new drug and those who took an existing one. If the t-test reveals a significant difference in recovery times, the company can confidently say the new drug is more effective. In summary, the t-test is a powerful statistical tool that allows you to compare the means of two groups and determine if their differences are statistically significant. It involves stating your hypotheses, determining the level of significance, calculating the t-statistic, comparing it with the critical value, and finally, interpreting the results. Whether you're a researcher, a student, or just a curious individual, understanding the t-test can provide valuable insights into the world of data and statistics.